2, 1. All right, so today we are moving on. So we spent the last 2 days on arithmetic sequences, and today we are going to look at geometric sequences, okay? So when you think of a geometric sequence, okay, we kind of hinted at it the other day. We had a nice, smart friend of ours go ahead and jump to it. So I want to make sure I give you the correct definition when I hear, how do we determine a geometric sequence? Well, I want to start by telling you exactly what it is. It is a list of numbers with a common ratio. Okay? So before, when we did arithmetic, we had a common difference. Now we have a common ratio. What letter do you think we're going to use? R. Okay. Now, here is essentially what this is saying, and I'm just going to put it in a bullet point, is you are multiplying by the same number from each term. So what that means is, if you were multiplying between one terms by 3, then when you get the next term, you multiply it by 3, and by 3, and by 3. Same thing as you've seen before. Now, just like you could add a positive or a negative number, you can multiply by a positive or a negative number. The other thing to keep into account, and I'm just saying this, I'm not writing it down, is there a way that I could possibly divide and it still be geometric? Yeah. Yes, because division is really multiplying by a fraction. Multiplying by 1/2 is the same as dividing by 2. Okay? So, as long as that pattern holds, that's something that we can look at. All right, now, let's go ahead and jump into this next thing, all right? What is the formula that we are going to be using, all right? It is very similar, not too much different, okay? As in, like, it looks the same, but they're going to be clearly different. So, for geometric, A sub n is equal to A1 times R, where R is raised to the n minus 1 power. Okay? A sub n is equal to A1 times R to the n minus 1. Okay, now, obviously looking in here, I'm going to give you a few definitions of what things are. Okay? A sub 1 is equal to the first term. Everybody good with that? Okay. R is the common ratio. Now, I want to bring something up. We talked about R can be negative, right? Whenever you plug this in, if you plug in a negative right here for R, you need to make sure you put it in parentheses, okay? The other reason is that important is if you write it on your paper in parentheses, when you use your calculator to help you, you will also need to put it in parentheses. Okay? And as we go through this, you will see your calculator sees parentheses -2 close parentheses squared, different than it just sees -2 squared. All right? And I can show you some of that. We can do some one-on-one stuff if you need to see that more. But the parentheses means the negatives included in what you're squared. It will change your answer. Okay? And then just like before, n is equal to the term number that you are looking for. So if you're looking for the 76th term, n would be 76. All right? Okay, so there's a lot of that basic information. We're going to use that more kind of on the back of these notes. So let's go through and let's talk about some problems that you will see here. The first, okay, it says, state if the sequence is geometric. Is there a common ratio? Now, with it being multiplication, this at times can be harder to see. Sometimes you see the first one, but then you get really big numbers and you're just not quite sure, right? Let me tell you the easiest way to figure it out. To find R, if you were unsure, you need to take the second, divide it by the first. And then you do the same thing going forward. You take what the term would be, divide it by the previous. The term would be, divide it by the previous. And those should give you the same thing. So what I mean here in this first example, if I went 24 divided by 4, I would get out 6. Well, then that means 6 should be my answer for every other one I divide. So then I would go 144, but what do I divide it by? 24. And guess what you get out? 6. And then you would go 864 divided by 144, and guess what you get out? 6. So since all of those are the same, that means that yes, this is geometric, and the common ratio is the number 6. Questions? Okay. Now, to show you one that possibly might not work, let's look at this next one, all right? 4 divided by 2 is 2. But then when you go 12 divided by 4, you get out 3. Those are different. So you would say for this that it is not geometric. All right. Remember, geometric is all multiplication. Okay. All right. Next one. It just says, hey, find the common ratio. Well, if it is asking you to find the common ratio, then that means that this is geometric, correct? All right. So, same idea. I wouldn't change anything up if I were y'all. I would do the exact same thing I did just to check it and see. Negative 6 divided by negative 2 is negative 18 divided by negative 6 is negative 54 divided by negative 18, positive 3. Those are all the same, so your ratio is 3. All right. Same idea here for number 6. Okay. Well, negative 18 divided by negative 3 is 6. Negative 108 divided by negative 18 is what? 6. And then negative 648 divided by negative 108 is, those again are all the same, so it is geometric, and our common ratio is 6. Bam. Okay. All right. Given the explicit formula for the geometric sequence below, find the common ratio. Now, here they have your actual sequence given to you. Here's what I want you to know. Remember when we did the explicit formulas for the arithmetic? What did we do? You were given the formula and then everything was simplified, right? You had to distribute the d value, combine like terms, yada, yada, yada. Here is why geometric's a little bit easier. The formula is a sub n is equal to a1 times r to the n minus 1. Guess what can never happen? It can never be more simplified than it is right now. Okay? Because you can look and say, hey, a sub 1's got to be separated because before I can multiply it by r, r's got to be raised to whatever the exponent is. So they will always be separated terms. That means looking at this is super easy. Your r value is always whatever n minus 1 is raised to. So in this case, r is 4. Well, keeping that super simple, what would r be in number 8? 2. Taking it piece by piece, step by step. Is everybody okay? Let's go on to the next ones. All right. So looking here at number 9 and 10, they say you are given the first term and the common ratio. They ask you to find the explicit formula. Well, the thing to remember, the explicit formula, A sub n is equal to A1 times your ratio raised to the n minus 1 power. Well, just like before, what are the two things we need? A sub 1 and your ratio. Do we have those? Yep. Are we going to have to simplify this? No, just plug it in. So you could say that A sub n is equal to negative 1 times 2 to the n minus 1. Now, let me tell you something that I do from time to time. If this had been negative, what would I have around it? Sometimes I just put the parentheses to get in that habit. Okay? Now, I generally don't put them on the front term because the front term just gets multiplied by the second one whenever it gets all the way through. So, take it for what it's worth. That's kind of what I do there. All right? Not trying to confuse you or anything. But that's just kind of what I do, something to help me. All right, looking at number 10, do we have our first term and our ratio? Yes. So we are good to go. It's all just plugging it in. A sub n is equal to 3 times 5 to the n minus 1. Any questions? All right, now, this is where we get to at least make it a little bit funner, okay? Here, they ask you to find the explicit formula, all right? Well, what we got to figure out is what is the common ratio. Now, let me sidestep here and tell you kind of where this is going in the future. Right now, this is easy, right? Because we know it's geometric, right? Everybody with me? As we go in the future, it might not be geometric. It might be arithmetic. So you're going to have to check both of them in the future where we're going. I'm just planting that seed in your head so that you know in the future. All right, so let's find our R value. Well, if we go 9 divided by 3, we get out 3. 27 divided by 3 is? 27 divided by 9. Thank you. 3. Thank you for correcting me. 81 divided by 27 is 3. So, looking at these things, we know that our ratio is 3. Do we know what our first term is? 3. Okay? Huh? You said 3, right? Yeah. Sorry, I'm crazy. All right. So, they ask you for the explicit formula. So, now it's just like above. We just had to find what the ratio was. So, A sub n is going to be 3 times 3 to the n minus 1. Bam. Is that very hard? No, I know. All right, number 12, okay? Same idea here. You've got negative 2 to go to negative 12. So to figure out what R is, we've got to take it and divide them. I got out positive 6. Same thing with this next one. Negative 72 divided by negative 12 is 6. Negative 432 divided by negative 72 is 6. Okay? So with all of that there, we now know that our common ratio is 6. What is our first term? Negative 2. So A sub n is going to equal negative 2 times 6 to the n minus 1. Any questions there? Anybody got anything? Okay. All right. Here we go. Now, I'm going to do one, then I'm going to give y'all a minute to do one, so on and so forth, so that we can do this. Okay? All right. So this next direction, say, given the explicit formula for a geometric sequence, Find the term named in the problem, aka plug in the number for n. All right? So, looking here, which term are they asking us to find? A of 11. So, as we do this, we're not finding A of n, we are finding A of 11. So, that is going to equal negative 2 in parentheses to the 11 minus 1. Now, before you try and raise it to a power, you need to simplify that power. So this is really negative 2 to the 10th. Listen to the words that are coming out of my mouth. You have to keep this in parentheses when you use your calculator. I'm going to go on a tangent right here and show you why. In your calculator, if you go parentheses negative 2 squared, you get out a positive 4. In your calculator, if you go negative 2 squared, you get out negative 4. Okay? Let me tell you why. Your calculator doesn't associate this bottom one as negative 2 squared. It associates it as 2 squared with a negative out in front. That is different than saying, hey, it's really negative 2 that needs to be squared, because two negatives will make a positive versus just a positive 2 being squared with a negative out front. That's why this is so important. Are y'all with me? Now, once you plug this in, what should you get out? 1,024. So A of 11 is 1,024. All right, now I'm going to pause this and give you a minute to work out 14. Ready, set. Okay, so after doing that, look in here. You guys all know that you're trying to find A sub 12. So here you're looking for A of 12, which is going to be equal to 3 times 2, but then it's going to be 12 minus 1. Well, that's really 3 times 2 to the 11th. Okay? Then, if you raise 2 to the 11th power, what do you get out? What? 2,048? You get 2,048. And then if you multiply that by 3, you get out 6,144. So A sub 12 would be 6,144. Okay? All right. Okay, now watch this. Okay? Seeing this here, 15 and 16 are kind of the same idea. There's just a little bit more work you've got to do. So here they ask you to find the term in the problem. However, all they give you is the sequence, right? They give you how the sequence starts. Now, there are two ways you could do this. If you wanted to, you could list out the 11th term of that entire thing. Do I recommend that? No. What I would do is just find the formula and then plug it in. So to find the formula, I would take negative 8 and divide it by 4, and I'd get out negative 2. Then I'd take 16, divide it by negative 8. It is also negative 2. Negative 32 divided by 16 is also negative 2. All right. Now, cool thing there is now we know that our ratio is negative 2. What is our first term? 4. So, A sub n would equal 4 times parentheses negative 2 to the n minus 1. However, we don't want that. We want the 11th term. So that's going to be 4 times negative 2 to the 11 minus 1. Well, that's really 4 times negative 2 to the 10th. Hey, we've already done negative 2 to the 10th, right? So it's really 4 times 1,024. And then what do you get when you multiply those? 4,096. So A of 11, A sub 11 is 4,096 for this geometric sequence. All right, questions? All right, I'm going to give you another minute right now to work on 16. Ready, set, go. All right, so let's take a look. What'd y'all get? All right, so let's take a look because I like that answer a lot. All right, so right here, first thing, let's find our common ratio. So 3 divided by 1 is 3. Now, I'll be honest with you. If you know it's geometric, like they tell you, you could stop right there because what did we just find? Yeah, we found our ratio. So A sub 1 is going to be 1, and then your common ratio would be 3. So what you would get here is A sub n is equal to 1 times 3 to the n minus 1. Okay? Now, looking at this, they ask you to find A sub 10. All right? That means it's 1 times 3 to the 10 minus 1. Now, I think I heard somebody earlier say they got the answer of 27. That would be incorrect. It is not 3 times 9. It is 3 to the 9th power. And when you raise 3 to the 9th power, you get out 19,683. Then when you multiply by that by 1, it stays 19,683. So A sub 10 would be 19,683. Bam. All right. So what we are going to do now is have some practice on this. The other thing I want to remind you of is yesterday you were given a block worksheet that needs to be uploaded to the support class. Please make sure you do that. Have a great weekend.